Hello and welcome to our introduction lesson about the project. As I told you in the first lessons, we will learn Matlab using a real project from the transportation systems. You had 2 lessons about the interactive mode of Matlab, which means you had to learn how to use the environment of Matlab to enter some commands, to learn the first commands at all, and things like that, so that you can deal with the environment of Matlab. The second lesson was about the scripting, which means you learned while loops, for loops, if-else conditions, all of these things, so that you can write own programs. And now we will use this knowledge to work on real data from a motorway coming from the A9 in Bavaria in Germany. And therefore, we have to get this data in our computer. So we have a data format, a special data format, and we have to read it. Therefore, we have to prepare the data, which means we have to convert it in a version which we are able to read with our current knowledge. Then we want to see the data, so we plot the raw data as they are. And after having the data in the memory, we can of course work with this data, which means we can calculate mean values, we can calculate an aggregation, which means about special intervals over the raw data, so that we smooth the shaping of our data and that we get more or less information. And then we can store, of course, intermediate calculations or intermediate calculated data, so that we have it later on again, for example, as an ASCII file. And finally, we want to use all of this aggregated data to plot a new colorized color plot or contour plot to see special effects like traffic jams, congestions, shock waves, things like that, so that we can interpret the traffic situation. First of all, we are here in this area around Munich. So it's the motorway starting in Munich to the direction of Nuremberg. And we have different sensors on this motorway which we can read out. For example, the traffic volume or the speed on specific sections. Then we will get the raw data. So the blue parts here are the raw data with the different speeds, one speed information on the main lane, for example, per minute. We can now calculate the mean values. This is the depth function, this red line. And with all of the sensors over a whole day, we can get now a final plotting, for example, such a color plot, where we directly see the congestions, especially on a special time zone and especially here on a special distance to Munich. So what are the different tasks? First of all, we have to read the data. Therefore, we need the information about the positions of the sensors. This means each sensor has an identifier, a detector number. In our case, it's called in Germany Messquerschnitt, which is the sensor ID, the sensor number, and we have a special distance of the sensor. So if you accumulate all of the lengths, you will get the distance to Munich. The sensor number starts close to Munich, so 50, for example, is Munich, and the last one here, 69, is in about 25 kilometers away. We have different information per sensor. First of all, each sensor offers values per minute. First of all, the measured local speed, then the smoothed local speed, which is also already an adaptation done by the sensor, then the traffic volume at main lane, the traffic density at main lane, the traffic volume at exit and entry points, and the length of the sensor, or the sensor sections, sorry. So if you have the lengths and if you accumulate this, you get the complete distances per sensor from 0 distance, which is Munich. The format which you will get is a simple Excel file. In this case, the data are quite old, but it doesn't matter. Also, the new versions have the same style, and therefore you have to read an Excel file. You see here on the left part that you have minutes or the information about the timing. So you have here the minute column, one information per minute, and then you have a block of sensor informations. This means you have 9 values per sensor, and then the next sensor follows. So each column is an information about one value, one item of a sensor. The first one, as I told you, is the measured speed. The next one is the smooth speed. The next one is the traffic volume, and so on. So at each 8th position, you will get a new sensor information, starting again with the speed, for example. Okay? So therefore, you have to get a version to read the data. We have not learned about reading Excel files directly with Matlab. And therefore, the first step might be to simplify this Excel file so that we can read it. So think about, what did we learn? We learned about load and save. Load and save are simple Matlab versions of reading methods to get file information into your program. And this file must be something like a table. And look, what's this? It's a table. So if you can store this as a table, it's quite simple to read it. And the table should be a text file. So check if there is a possibility to convert this. Therefore, you have to prepare the raw data. This is a first possibility. So therefore, store the whole Excel file as a tab separated, so with a tabulator separated table, so that you get the whole information as a table. But think about the information what we had about ASCII. ASCII strings or ASCII vectors are pure vectors with just the simple difference to a normal vector that you have each position with an ASCII sign. So therefore, you cannot mix different lengths, because then you would lose the well-defined sizes or dimensions of the matrix. So therefore, what do you have to do? In a first step, we assume that each file would look similar, and therefore we kick out all of the text information. So delete the first 2 lines, which is the information about the sensor ID and about the column item name, and assume that it's always in the same style, and therefore you have just numbers in your file. There is one special thing about the different keyboard styles. So if you have, for example, a German style, then Excel uses the comma instead of the floating point. And therefore you have to take care on this, because what did you learn in one of the first lessons about matrices? The comma is a separator between different columns. So therefore, if Matlab load, for example, reads this file, a comma will be interpreted as a new column. And therefore, you have to deal with this. If you have the American English style keyboard, then it's everything okay. So it means you have a dot, you have this floating point, and therefore you can read it as it is. Therefore, take care on this, because you have maybe 9 columns if you have the German style, or you have 8 columns per sensor if you have the American style. And it depends on if I store it, for example, with my German keyboard, or if you store it with your American keyboard. This is one version. This is the simplest version with a method, with a function which you already know. After storing this Excel file as text file, you can directly read it with load. Another version is, if you don't know how to read Excel files, maybe Matlab already offers something to you. Matlab is a very, very sophisticated suite, and therefore you can directly find a lot of functions and methods. And with this, you can read all of these things maybe directly. So first of all, search the internet, and then if you find something to read Excel files directly with Matlab, and it should be just one call, so one function, then check the Matlab tutorial on Matlab help pages how to read this stuff. Okay? So you have two versions, and you should try to program these two versions, because if you will get another sensor section or another day or another motorway, you will have to deal with this. So these preparations, all of these steps to do manual changes will cost a lot of time, especially if you want to, for example, calculate the situation for a whole year. You will have to do it 365 times. Okay, so think about to optimize it. But nevertheless, you can start with the simple things and then go to the more sophisticated ones. So what are the next steps? You read this raw data and you plot the raw data. So you read the raw data and then you fetch just the information about the speed. This information is always the first column of your sensor. You have values per minute, so therefore for a first plot you even don't need the knowledge about the minutes, you just need the position of this information. So it means line number. So each line is 1 minute, so therefore you should have 1440 lines, because 1440 lines means 1440 minutes. We start with minute 0, so therefore you should have a value from 0 to 1439, and then you will have 1 day, because 1 day has 1440 minutes. And therefore you can do an easy plot. You even don't have to set an x value, just use the y value and then you directly get this plot. You see here the time in minutes for this special day. Try directly to set the axis names and also the title. After this plotting, we of course want to manipulate the data, meaning we want to calculate new data from these existing values. So therefore we want to get additional information. We want to change the data so that we can use them for individual information. And one simple thing is to calculate an aggregation. What is an aggregation? It means you have mean values over special time intervals. So you calculate always a mean over, let's say, 15 minutes. So this is also the starting point. Later on, we want to change our code that we will calculate also intervals of different lengths. So for example, of 1 minute to get the raw data, or 2, 3, 5, 10, 15, 500 minutes. What you do with this is that you smooth the data. So you lose information, but you focus on the main parts. So for example, if you increase the length of the interval, it means that you will get less information, but you focus on the main parts. So you will see the congestions. If you reduce the length of the interval, you will get more information, for example, about the shock waves and things like that. So you can play with this stuff. And later on, at the end of our project, we will prepare a complete software suite so that you get a menu and you select what you want, so that you can process it several times and it's not so strict in the programming, so that the user of your program does not need to reprogram or to change the program. But first of all, let's start with the simple things. It means we will calculate 15-minute intervals, so 15 elements. We take these 15 elements, we calculate the mean, and then we will set this mean for these 15 minutes so that we get a nice step function. This is quite simple because Matlab automatically interpolates, and therefore we will have not a real step function. The last, let's say, the step in this intervals will be not really an orthogonal line, but because the plotting is not so detailed, we won't see this. So therefore we will get per 15 minutes one value, which we spread over 15 minutes so that we see a nice step function. The pure arithmetic mean is not so helpful sometimes because it might be better to normalize these values. And what can we use for the normalization? We can use the Q-weighted speed velocity mean. You learn this in other courses. Here is the formula. So if you program this as an own function, for example, Q mean, you can use the same style of call with the old classic arithmetic mean and with the new Q-weighted mean. So you extend the functionality of Matlab with own stuff. And this is what we want to learn here. So writing own function, because later on for the software suite doing all of these calculations, we will need this again. So we will first start with the simple things. We start with the scripting, so per step things which I explain at the moment, we do in different scripts which call each other or which we can call from outside from the command window. And later on, if we know how to do all of this stuff, we can combine it and we can change it so that we will get a function-based software suite. Okay? So if we have these mean values, if we have this intermediate data, we can try to store the data again. So we write the aggregated values again into a file. Not an Excel file, because we know reading from ASCII files is much easier. So therefore we store it in an ASCII file. And then we can use it later on. So we can write a script which directly reads the intermediate values instead of reading the raw data and calculating again the whole mean stuff. And finally, we do this for all sensors. So doing it for all sensors, do you hear? We need the for loop because we know how many sensors we have, and therefore we do the for loop. We do it for all sensors. If we don't know how many sensors we have, we can use the while loop. So for example, we jump step by step and we run as long as we find columns which are filled. So let's do this for all sensors, which means we do the tasks to read the data, to plot the data, to process the data for all of the sensors we have. In our case, we will have 19 sensors, so you have to run this 19 times. And of course, we store it again in our new intermediate file. And finally, we want to do a nice contour plot. In Matlab, it's called p-color plot or color plot. And the color plot is quite simple. It is in principle a three-dimensional plot, but the third dimension is represented as color. So this means, so I shift me to this position here. So this means you have a x-axis. In our case, it's the time, the 50-minute intervals. So we can have minute intervals, and this is then the 15-minute part. And on the y-axis, we have the location of the sensor, so the distance. And what does it mean then if you have here a point with x, y? You have a third dimension, the z dimension, and the z dimension is a color information. And the color information represents the mean value. So you have for each time and for each location, you have one dedicated information which tells you the speed. And therefore, if you do it for all positions, you will get something like a mesh here. And for each mesh point, you will have this mean information. And this mean information is colored. So if you do it for the whole stuff for a complete day, you will see something like this. And you will have different days available so that you will see different situations. For example, on a Friday, it will look a little bit different. And maybe for a Monday, it will also look a little bit different. Because, for example, on a Monday, you will have main traffic, for example, to Munich. And for a Friday, you will have the main traffic from Munich. So leaving Munich. And therefore, you will have maybe congestions at different time positions and at different locations. And what also is available here is this light blue or part here, which shows you, for example, speed limits. And if you see that there is a speed limit and there is no speed limit, you also see that there is an automatic speed limit sensor mechanism available. So that there are speed limits which are switched on in special traffic situations and speed limits which are switched off. If you have a block which is always in this light blue, you know it's a static speed limit. So you will see a lot of additional information. And if you change the interval, you will also see maybe this information about these shock waves. So if there's a braking scenery, the stopping moves back into the other direction of the flow, of the traffic flow, and you will see it here. And therefore we can use this nice color plot for the interpretation of the traffic situation. To get this nice color plot, we have to deal with colors. So we have to think about what are colors in Matlab. Therefore we have to represent colors as a color map. A color map is a red, green, blue matrix with 256 lines and, as I said, 3 columns, so one for red, one for green, one for blue, and this represents the color. So if you use the standard color map, you will see that the traffic jams here, the congestions, will appear as dark blue and the rest will be yellow or something like that. Therefore we have to change this color map so that we see the situations of slow traffic in a highlighting color like red and the situation of fast moving traffic in a normal darker color style. So therefore we have to deal with these color maps. It's another thing which we will do. And finally, of course, we can interpret the data. You can think about and you can take your knowledge from other courses into this course. If you have done all of this stuff, step by step, learning step by step more about Matlab programming, we then can think about to improve this. So if you just do a scripting, you will see that if you get new data, it will be really ugly to read this new data because you have to rewrite your whole program. You have to update the program. And then if you want to read the old data again, you have to change the program or you write new scripts, things like that. So the versioning is a real problem. Therefore, what want we do or what will we do to prepare this, to improve this? We will prepare functions which we can call at different positions in our code. So we will convert the pure scripts into functions. Why don't we do it directly at the beginning? Because you're a beginner and therefore I think scripting is easier than thinking always in functions. If we have functions, we will have also the possibility to avoid memory blocking. Because each time if you run a script and you create a new matrix, the matrix will be kept as long as you will clear it. In functions, each created memory will be deleted again, which means it will be automatically freed. And therefore, we do not waste this memory. Okay, and then we will create this function and then we will write one main program which is in principle nothing more than a menu. In our case, a really simple menu, where we have numbers and what the number means, and if you enter the number, it will calculate and do what the menu wants. So it will call a function, and then it will process this step. And therefore, we will be able to extend each time our new situation comes in. So each time when we get new data, we will calculate a new version of or we will read a new version of our data, and we just add it as a new menu point. And on the other hand, we don't have to rewrite our program, because we can have a look onto the data again just by pushing the new menu button or the same menu button with a different interval length or things like that, so that we don't have to do programming. And this is what we want to have at the final step, that our user, our consumer of the program, will not have to change our program. We guide our user. In principle, you are your user, but if you write professional software, then you will have to do this. You will have to guide your user through your program, and this is what we want to learn. Around Christmas, we will do an intermediate step, because until this time you will have a little bit more knowledge about programming, and therefore you will get a small contest. So you will have to do a small riddle. You have to do a programming where you should learn the dealing with functions, which is then necessary for the next steps to create the software suite. And then we can do small other aspects from transportation systems. And I think we will do something like the traveling salesman problem. So we will solve this traveling salesman problem with our Matlab knowledge. And this is what we want to do in the next steps, in the next lessons. And therefore, feel free to write your own programs, accept your errors, deal with these errors, learn from these errors. I do the same. Let me know if you find errors in my code. It's always nice that we can discuss about these situations. And I just can say, write your own code. You have to climb up this hill. You have to learn programming just by doing programming, not just by watching my videos and saying, oh, I understand everything, or oh, I don't understand anything. And you have your own style of programming. So each programmer has an own style. That you don't forget what you have done. Always use comments. So deal with commenting, deal with the scripting methods. So therefore, you should write a little bit efficient and readable code. So add comments which explain what you do there. The comment should not just explain what you directly see. For example, now there is a for loop. It should explain what the for loop does. Write understandable matrix names or vector names. It's fast if you just write A equals something, but it's much better if you directly write this is matrix containing speed values. So the matrix should have the name speed and maybe underline kilometers per hour, so that you directly see the unit and the name. So deal with this, write understandable variable names, because after half a year, so for example to prepare the exam, you won't understand your program anymore. And it's the same for programmers in real life. So if they read their own program in a year or two, they won't understand it anymore. Then structure your code with logical units, for example with command lines or with single scripts, or later on with Matlab functions. Avoid loops if there is a possibility to use these dotted operators, so that you have this element by element operation. Always initialize matrices as often as possible, because then you won't have this reorganization of the memory all the time, which speeds your program up quite fast. So it's tremendously makes it really fast compared to not initializing matrices. And use the matrix operations and matrix standard functions. If there are functions, first of all, check if there are functions and then use them instead of writing own code, because they are optimized and they are much faster than what you write usually if you have for loops. Okay, so that's it. Feel free to send comments and have a lot of fun with programming. See you for the next lessons.